Okay, so today what we're looking at is strategies for solving trig equations. And we're not talking about just the real basic type that we've done a little bit of, where you're just using unit circle, or where it's just sine of x equals, root 3 over 2, and then you're just picking out your two angles. That's just the last step of this whole process. Okay? What we want to work on today is starting to develop a strategy for more complex equations that we can solve that involve trig functions. Okay? So, a couple of tips here as we get into this. First of all, don't forget about the quadrants. Alright, when you get an answer to an equation, you should not only get the first answer that your calculator might give you, but you should also pay attention to the directions, and if it asks for all of the answers from 0 to 2 pi, make sure that you give all the answers from 0 to 2 pi. Or if it gives you a different domain for your angle, you should be giving all of the answers within that domain. So don't forget about your 4 quadrants. Another thing that I will say is, unless you're told to do otherwise, I want you to assume that it's going to go from 0 to 2 pi. Alright? So always use that, unless the problem gives you a different range, or unless, as we'll see later, they ask you for a general solution. Okay? So, then we have this general strategy. Alright? We have the general strategy is not super complex in just listing steps, but it gets complicated, okay? The first thing that you want to do, if possible, and we'll take a look at cases where it's not possible, but if possible, we want to get the equation in terms of just one trig function. So if you've got an equation that has sines and cosines in it, you need to try to work on that and get it to where it's just in terms of one trig function. Now, since we have an equation that may involve squaring both sides, or that may involve, if you divide, you could make it in terms of tangent. Alright, it'll all depend on the situation. Okay? The next thing is identifying what kind of equation you're dealing with. Are you dealing with a linear equation, a linear trig equation, or a quadratic, or maybe even another polynomial? And that's where you need to incorporate some strategies related to those, okay? If it's a linear one, you're going to get the trig function by itself and then take the inverse trig function. If it's a quadratic or another polynomial, you're going to get it equal to 0 and look to factor, or possibly even use the quadratic formula. Okay? So that's kind of a general strategy, but that at least will give you an idea when you're looking at a problem of where to begin. Okay? That'll give you a chance to look at where to begin. So let's start with kind of a simple one. This one, we have 2 sine of x minus 1 equals 0. Would this be linear or quadratic form? Okay, it's linear. Sine is just to the first power. So we're going to get the sine by itself, okay? And that's relatively simple here, right? So we add 1 and divide by 2, and we get sine of x equal to 1/2. Okay? So now, if our angle is between 0 and 2 pi, and sine is equal to 1/2, then what's our angle going to be?
The inverse of sine x, or 1/2, the inverse of 1/2.
Okay, inverse sine of 1/2.
30 degrees, or 5,
Okay, 30 degrees in degrees, but it's 1/6 pi, pi over 6. Okay, so x equals pi over 6. But we should have another answer, right?
Yeah, 5 pi over 6.
5 pi over 6.
That's like a negative.
Okay.
No, because...
Well, no, it wouldn't be negative.
My bad.
Sine is positive in the first and second quadrants. This is where I said, remember, all students take calculus. We had a positive 1/2. we got one answer in the first quadrant, we should have another answer in the second quadrant, because sine is positive there as well. So the reference angle of pi over 6 gives us 5 pi over 6. So those are our two answers. Okay? Now, those are the only two answers between 0 and 2 pi. Okay? Now, here you see a general solution. This is something that may seem a little odd, but it actually, if you think about this, if we didn't have from 0 to 2 pi, because we're dealing with periodic functions, there's actually an infinite number of solutions, right? Because each of these has an infinite number of coterminal angles. Alright? Well, how did we find a coterminal angle?
We subtracted it minus the horizontal.
Two.
We
Yeah.
took the
2
horizontal
pi.
and subtracted it from.
Yeah, to subtract by the reference angle.
Okay. That's how we found the other one with the same reference angle. But what'd you say?
Add or subtract 2 pi.
Yeah, just add or subtract 2 pi. Okay, that may have been what you were trying to say, but okay, so we've got here x is pi over 6, but it's also every coterminal angle to pi over 6. So guess what we do? Alright, everyone look here. We have pi over 6, and we're going to put a plus 2 pi n. Okay? A plus 2 pi n. Well, n
Many times you want to go around the circle.
is an element of the integers, okay? Z is the symbol for the integers, n is any integer. So this takes care of adding or subtracting 2 pi any number of times. We could go around 3 times and we'd get a coterminal angle to pi over 6. That will be a solution to this equation. Okay? Now, we also have to do the same thing with the 5 pi over 6. Okay? 5 pi over 6 plus 2 pi n. Okay? So that would be the general solution. A specific solution, if you're given a domain or the domain for x, you would just use, all students take calculus and figure out all of the answers within that range. Okay? So, pay attention to directions, make sure that you're giving your answer the proper way. Okay? Any questions so far? Alright.
Checks out.
Let's try some others here. Find all the solutions of sine of x plus a root 2 equals negative sine of x.
Add sin x to both sides.
Okay?
Can you do that or no?
Well, let's think here. You can. Okay? Let's think here. Is this a linear or quadratic type?
Linear.
Linear, okay? So we want to get all the signs on one side, and then get it by itself. Alright, so yeah, let's subtract the sine from both sides to get all the signs over here on the right hand side. And we have root 2 equals a negative 2 sine of x.
And then divide by -2.
Divide by negative 2, okay? So divide by negative 2, divide by negative 2, and we get sine of x is a negative root 2 over 2.
Huh.
And that, so that would be in the second quadrant and the fourth quadrant, right? We know that. That'd be,
Well, hang on. Where is sine negative?
Third and fourth.
Third and fourth.
Grand.
Okay,
sine, not tangent.
Yeah.
For now.
that's alright. So x is going to be the inverse sine of negative root 2 over 2. So you're right, we are in the third and fourth quadrants. What's our reference angle here?
45 degrees, or 1/4 pi.
45 or pi over 4, okay? Since they said 0 to 2 pi, we should be in radians, so pi over 4. So what's the angle with the reference angle of pi over 4 in the third quadrant?
5
Fourth
pi.
pi.
5 pi over 4.
Okay?
7
You
pi
don't
over
have to
4.
bother.
7 pi
It's okay.
It's like
All right?
You don't have to prove yourself anyway.
7 pi
Okay.
over 4.
So,
I'm for your name.
guys, come on. So we've got 5 pi over 4, that's in the third quadrant. We also have fourth quadrant, which would be 7 pi over 4. Okay? So 7 pi over 4.
The general.
Okay? Now, we don't have to give a general solution because we were just asked for the solutions in the interval. Okay, so we'll just give those two answers. Okay? All right. Let's try one here
Yeah.
without a linear.
Parabola.
Okay, we've got a quadratic at this point. Don't forget all the different strategies for solving a quadratic. Okay? You could try to factor. You could use the quadratic formula. Or in this case, if there's no linear term to it, we have a tangent squared, but there's no just tangent term. In that case, you can get the squared term by itself and then square root both sides.
Tangent squared.
Okay? So if I were to do that in this case, I would have tangent squared x equals 1/3. And then I could square root both sides. So tangent of x is, don't forget, plus or minus root 3 over 3. Good. Square root of 1/3 is root 3 over 3. Now, in this case, it's real easy to forget that plus or minus part. Okay? If you think about it, it's kind of like the fundamental theorem of algebra is doubled. All your linear ones have 2 answers, your quadratic ones will typically have 4 answers. The only time that doesn't work is if we have a quadrantal angle, like pi over 2, it's the same reference angle in the first and second quadrant, so then you only have 1 answer. Okay, but other than the quadrantal angles, that's how it works. Okay, so does anyone know the reference angle where we have a tangent of root 3 over 3?
Where sine equals sine equals 1/2
45
and
degree. No, never mind.
cosine equals square root of 3 over 2.
Okay.
So
Alright.
that's
Equals
gonna
sine
be at either pi over 6. I mean not pi over 6. Pi over 3, 2 pi over 3.
No, you're right the first time.
Oh,
If sine
pi-
is a half,
Oh, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. But
Okay.
Because it's plus or minus, it could be all of them.
that's right, okay? Because it's plus or minus, it'll be all 4 of these as possibilities. Okay? Because we end up squaring it, it doesn't matter if we plug in a positive root 3 over 3 or a negative root 3 over 3. The negatives will be canceled out. Okay? So here, once you identify that reference angle, you notice you have all 4 answers. Okay? Now, it would be nice, just as a mental exercise if nothing else, to make sure that you're recognizing which ones are coming from which. Alright, so tangent is positive in the, not second, in the first and third quadrant. It's negative in the second and fourth quadrants. Okay? So if you wanted to note that to yourself, that might just be a good habit to get into. Okay? One thing about the general solution, okay? We found the solution for 0 to 2 pi. Okay? If I were giving a general solution, notice I would not have to do all 4 of these plus 2 pi n. Alright, now notice here that the 2 positive ones are exactly pi units apart. Pi over 6 and 7 pi over 6. So, if I were to do pi over 6, and instead of doing 2 pi n, I just did a plus
6 pi.
pi n.
Oh. So
When it
6
was pi, when it was 1 pi, I'd get the 7 pi over 6. 2 pi would get a coterminal angle.
5 pi.
3 pi would get a coterminal to the 7 pi over 6. Alright, so you see I can actually get both of these in the same general solution. Okay? And then I can actually do the same thing with the 5 pi over 6 and 11 pi over 6. Those are exactly pi units apart. So I could do 5 pi over 6 plus pi times n. And that'll cover all of those. Okay? Yes, Donald? Well, it actually has to do with, remember when we looked at the graph of tangent? Okay, we had the graph of tangent, and it looked like this. We had these asymptotes. Okay. And then we had okay? So we had that. Remember, because it looked like this, the period was only pi instead of 2 pi. For sine and cosine, the period was 2 pi, but for tangent, the period was only pi. So in this case, we're going to see things repeating every pi units instead of every 2 pi units. Okay, so that's why for tangent, we can just do pi n. Alright? Okay. Now, that's the end of this lesson. What I want to do at this point is give you some time to practice a little bit, okay? So we're going to start practicing with, if you go to the required IP document, okay? We'll give you some time to get started. It'll help you guys get your minds going with this. And then we'll look at some other stuff later.